Hello, today I'll be going over LeetCode number 53, maximum subarray. In this problem, you're given an array of numbers, and you're tasked to find the contiguous subarray such that the sum of the elements in it is the largest, and you want to return that sum. So for example, in our example input nums over here, we notice that if we pick a subarray of 4, -1, 2, and 1, and we sum that all up, we will get the largest sum possible, which is the largest sum 6. So now we need to figure out how to find this contiguous subarray. So in this problem, we're looking for the subarray in which the sum of the numbers inside of it is the largest. So in order to do this, we can ask ourselves a question each time we loop through the array. So first, let's just create a variable. Let's call this running counter. Now what we're going to do with this variable is we're going to go through the array and ask ourselves a question, whether we should start a new subarray at that point or add it onto our previous one. And what I mean by this is, let's just start off with -2. So suppose our subarray consists of the element -2, which is the first element in our array. We look at the second element, which is a 1. We ask ourselves, would it be better to add 1 to -2 to create a subarray of length 2? Which would have a total sum of -2 plus 1, which is -1? Or would it be more beneficial to ignore the -2 and just start a new subarray consisting of only the number 1? So would it be more beneficial to add it on to the previous subarray or just start a new subarray of value 1? And we notice that since 1 is greater than -1, it is more beneficial to start a new subarray with value 1. Now we look at the next value, which is a -3. We ask ourselves, would it be more beneficial to start a new subarray with a value -3 or continue the old subarray, which we have as 1, and add the -3 to it? So we notice that since -2 is larger than -3, we notice that it's more beneficial to add it to our existing subarray. So our new subarray becomes 1 minus 3, which is -2. Now we move on to the next element, which is a 4. We ask ourselves, would it be more beneficial to create a new subarray starting with the number 4? Or would it be more beneficial to add it onto our previous subarray, which has a value of -2? So we notice that -2 plus 4 is 2, and just 4 by itself is 4. So we notice that it is more beneficial to start a new subarray with value 4. We move on to -1, and we keep repeating this process over and over again. We notice that it is more beneficial to add -1 to 4, creating the subarray of 3, value 3, than to start a new subarray starting with value -1. And if we continue to do this and continue applying this, we will notice that at the end, we will come up with another list of numbers. Now, in this list of numbers, the answer which we get will be the maximum number in this list. And the reason why is because as we go through the list, we make the choice whether to start a new subarray or to continue the existing one and add the element to it. And each time we're making the best choice we can. So at the end, when we get the value 6 over here and then it drops at towards the end, we notice that 6 is the highest value we can achieve if we make the best decisions when considering the elements we put in our subarray. Therefore, 6 will be the answer to this question. And this is the sample test case. So this is how we can solve the problem. And to implement this into code, the way we can write this out is, as we go through the array, we would be looking for the running counter. In order to calculate the running counter at a position, we would look for the maximum between the current running counter plus the new number and just the new number. So what this will do is it will look for the maximum between adding the new element to our existing subset or creating a new subset, which is the two values or two options which we have. So this is how we can find the value of the running counter at any point in time. And to find the maximum, we can just create another variable, answer. And as we go through running counter and calculate running counter for each of the indexes, we can just find the maximum value and put it in as our answer. And that is how we implement and solve this problem. Now let's go over the code solution for this problem. So in order to start off this problem, we need to initialize our two variables, the running counter and our answer. So let's start our running counter equal to nums at position 0, which is the first element in the array, as well as our answer. Now what we want to do is we want to loop through the array. Now, each element after the first element, we're going to check through it and ask ourselves that question. Is it more beneficial to create a new subarray, or is it more beneficial to add on to the last one? So in order to figure out, what we're going to do is we're going to set running counter equal to the maximum of the running counter plus the new number or just the new number. This first part basically tells us the value of adding on the number to the current subarray, and the second number basically tells us the value of starting a new subarray. Now from there, since we're looking for the maximum, we are going to set answer equal to the maximum of our current answer and the new answer we get through the running counter. At the end, we can just return our answer. And as you see, it is accepted.